Okay, so we'll go ahead and get started, and a request was made for dot diagram. So in order to do that, you will need your periodic table or a periodic table. You can just look at the one that's on the west wall over there too. So for dot diagrams. So there's a lot of concepts that we would see inside of this, and that meaning we see two parts of the compound. Is this covalent or is it ionic? Because that's going to make a big difference on how you go about doing this dot diagram. So you have a 50-50 chance. Just guess. Just guess. It would be an ionic compound. And how do we know that this is an ionic compound other than us just telling you? Well, what type of substance is the chloride ion? Is it a metal or non-metal?
It's a halogen.
Right, but that's where it's located, but that doesn't say if it's a metal or non-metal.
It's in the seventh column.
That's true, but that doesn't say whether it's a metal or a non-metal. It's a non-metal, that's right. So how would you know, again, other than us just telling you, whether there is a metal we're talking about or a non-metal? Even just looking at the periodic table, what happens if it's written in red? Well, use column 8 as an example. Who is all in column 8? So that's the clue. Gases. Those are written in red. So is that metallic or non-metallic? Yeah, certainly a non-metal. So then if you move one column to the left, like you had mentioned the halogens, when you look at either your table or over on the west wall, what type of substance would you guess fluorine and chlorine are just by observing that on that periodic table? And it's a non-metal. Why is that? Because what type of substances are fluorine and chlorine? They're halogens, that's true. Yeah, they're gases because they're written in red, just like column 8 is with the noble gases. Okay, bromine's a liquid. Okay, iodine, depending where it's at, room temperature, I believe. Then you can move over to column 6, and oxygen's on the top. Is that a metal or non-metal?
That's a non-metal.
Right. So then sulfur, it has non-metallic-like characteristics. It's still a solid because being in column 6, it still wants 2 electrons. But for the most part, when you look at all of those elements on there, if they're written in black, they're probably metals, or at least solids of some sort. So this is written in red. This is on the left-hand side of the table. So calcium is a metal. You have a metal and a non-metal. Therefore, we have an ionic bond. So what's the chart? We don't have to do this. We're just reviewing some of these concepts so that when we encounter this again, we can accomplish that task or goal. What does the chloride ion have for a charge?
It's got a -1.
Okay, so this has -1. Calcium has a charge of what?
+2.
Okay, so we know that that doesn't add up to 0. Simple math would tell you that. So what's your least common multiple between these? So what's 2 divided by 1?
2.
So that's why that 2 is there. What's 2 divided by 2?
1.
Would give you 1. Did I say 2 divided by 1?
I said 2.
Okay, 2 divided by 2 would give you 1 then. Okay, so how would we go about doing this? Well, what do metals like to do with their electrons? Keep them or get rid of them? Well, if it's got a positive charge, does that mean it has more or less electrons? And to help answer that, This is one of the things that we've done a long time ago. So would you like to see electrons or neutrons next? Electrons, then neutrons. Okay. So how many protons does calcium have? Now we're going all the way back to everything in the atom of calcium. Because what is its atomic number? That's maybe its atomic mass, but not its atomic number. 20. Why is that important? That gives you the number of protons. Okay? So if it is neutral, which one of these do we know we can write in? If it's neutral, it means the positive charges must balance out the negative charges. So the electrons have negative charges, so that has to be 20. So then in this case, you would have to have this information. So then your numbers of neutrons is what? And how would you get the number of neutrons? You got to be, because if we just say atom, we could say, is it 60 then? Which you can do. We could say, okay, the protons plus the neutrons has to equal its atomic mass. This is not always the case. You don't always get the same numbers every time. I think that's easy to forget that, especially when these elements get bigger, because we know with gold, that's Au, 79, and was it 2 to 18? I should have. What is the atomic mass for element 79? No, it's 197. That's right. So there's no way we're going to get 79, 79 here, but you won't get 79 there. That would just be silly by subtracting these two. You know you're not going to get 79. So don't always think that you're going to get the same number every time. It can happen, but not for all elements. The reason that we wanted to go over this is because you had correctly said that calcium's got a +2 charge. Okay? So that must mean, does it have 2 extra positive charges or 2 less positive charges? Because what happens? Do we gain or lose protons, neutrons, or electrons? Because when you said dot diagrams, does that deal with the protons, the neutrons, or the electrons? Electrons. So that means we can get rid of this for sure. Okay? Well, if this has a +2 charge, okay, well, if there's, and we will get to this dot diagram. We're just reviewing a whole lot of concepts here because we're choosing not to ask questions, and maybe we all understand this. Because if we do, how many of you can do the Bohr model for calcium? I must be overworking some students, but that's all part of growing up, I guess. Follow your slide rule. 1s what?
2.
Okay. 2s what?
2.
Then what? Okay.
3s2.
Do we keep going? Well, 4 times 2 is 8. 8 plus 12 gives you 20, so that must be correct then. So what this means then, how many positive charges are inside that nucleus? Okay? And how many negative charges are on the outside of this nucleus right now? Okay? So for us to get a charge of +2, that must mean that those 2 electrons, it's not that they disappeared, but they were given away to the chloride ion. Because now we still have 20 positive charges, but how many negative charges do we have now? So 2 times 3 is 6. So we could say that this is the number 6. So then what would 6 times 3 give you?
18.
We give you 18. So now if we had 18 negative charges now, oops, I meant to put that there. That's what I meant to do. What happens when you add those two together now? And what are we supposed to get?
2.
Positive 2. Okay? So that's why this calcium has a charge the way that it does. Okay. So what did we take away from that outer energy level? Specific, what type of electrons? It has a specific term. It's not just electrons. Valence electrons. So 2 of those were given away. So that must mean that those 2, we could say, are here. And where should we put the other one? Can we put that here?
No.
I mean, I suppose you could, but that's not how this element would look. Because if we put, or this compound, excuse me, if we put one dot on this side, where should we put this other one?
The other side.
Yeah, let's put them on the other side. Okay? Well, let's not forget to get rid of this then. Okay? So now where we see an electron, what are you going to place around that dot?
The chloride.
Yeah, you're going to probably put a chloride ion there.
There's 7 of them.
Okay? All right. So you said put a chloride ion where there's a dot, right?
And that's 7 electrons.
And why, you're right, but why does it have 7 electrons?
Because
It's in the 7th column. And now, how many are around this chloride now?
8.
Is that how many it wants?
Yes.
Yes, it does. So then what do we do on this side where there's a dot?
Do the same thing.
Do the exact same thing. And it doesn't matter if the X's are the same size. And you don't have to put boxes around them. That just shows you that now we've satisfied that octet rule. But calcium doesn't have any around it. But what do metals want to do with their valence electrons?
They want to get rid of them.
They want to get rid of them, and that's exactly what they did. Okay? So let me ask you this. Would this be really, really difficult to do? Magnesium bromide, would that be really tough to do? Why? Yeah, I agree. It would not be very difficult. Why is that?
Because it's like the same thing.
It's the exact same thing. It's just that we have different elements. Magnesium and calcium are in the same column. Why is that important?
Because they're both alkene earth metals.
Okay, well, they're both alkaline earth metals, but they have 2 valence electrons, both magnesium and calcium. Where's bromine located on the table?
The 7th column.
And then where's chlorine located?
7th column.
So this is the exact same thing, it's just the elements are different. Okay? So what I mean, solving this would be the exact same process, but the elements are different. I thought I better restate that. Okay. Well, what about if we had to do something like okay? So what's the charge of the hydroxide ion? And how many do we have? So this whole side has a charge of -2. Okay? What does barium have for a charge? Because where's barium? It's element 56.
It's on the second column.
So then, how do we know that it's a +2 though?
Because it's on the second column.
And because it's in the second column, and it also tells you that on your table. So now, is there any similarities between solving this electron dot diagram as opposed to this one? Because we do see some, if you want to call them parallelisms, similarities, whichever. Chloride has a charge of -1. Well, so does hydroxide. It's just that there's 2 of them there. -1 times 2 gives you -2. +2 times 1 gives you +2. All right. So what do metals want to do with their electrons? They want to get rid of them. So then, if that's the case, which it is, if we put barium here, how many valence electrons did calcium get?
2.
Okay, this is in the exact same column. So how many valence electrons is that going to get?
2.
Okay. Now, what column is oxygen in? So why is that important when you say the 6th one? Okay, so what we might do is where there's a lone dot, what might we place there? Yeah, we're going to make a bond. Okay, the problem that could happen is really you could do this. Okay, don't write this down. Okay, because that hydrogen can bond on here. It's what we call a hydride, but that's something that you really don't need to know. The problem with this is, where do you put your oxygen now? There's really no place for that to bond. So that's why putting the hydrogen there is really not the answer that you're going to want to, approach that you're going to want to take. So the oxygen comes next, because you correctly said it's in which column?
6.
So we'll go ahead and put an oxygen atom here. We've got 1 there. So how many X's remain?
6.
So 5 more. Okay. Then we'll just do it this way because I think that makes more sense that way. So there's 1 oxygen. What do we do with the other oxygen? Do the exact same thing. Put it over here. Okay? So how many dots and X's does that oxygen have?
7.
It's got 7. How many more does it want?
1 more.
Well, where's it going to get that electron?
The hydrogen.
Right. Why? Because hydrogen's in which column?
It's in the first column and it only has 1 electron.
It only has 1 valence electron. So there we go. Okay, that would be how barium hydroxide would look. Okay. So ionic bonds really aren't too bad. It's the covalent ones that are probably a little more difficult. So what we mean by that is, now this is somewhat of a trick question. So again, we'll duplicate things here. What would we call this? We should know what that's specifically called. It's methane. Okay? And we can do the electron dot diagram for that. Because you might be asking yourself, well, we don't have a metal here, but we certainly do have carbon. What column does carbon fall into?
It's the 4th column.
Okay? So how many valence electrons is that?
4.
Okay? So we just go ahead and do 1, 2, 3, and then 4. So where we see an X, probably going to want to create a bond. So we could do 4 hydrogens on this methane compound. Okay? Does that carbon atom have 8 electrons around it now? Yes, it does. Okay? So these get to be a little more difficult, these covalent bonds, should we maybe have something like this. Would you like to try that on your own, work on it together, or have one of your classmates come on up here and do this? Asking for input. Okay? We'll just hit pause here. Okay? Anybody? So, but that still, we need to have that initial question answered. Work on it together. You work on it on your own, or one of your classmates comes up here.
Together.
Okay? So you just want to see the right way that you do it, or probably the approach that you would take. Which do you prefer? Just show you how to do it. So then, should you see something like this? Oh, okay, well that must be how we do it. Yes?
I think I can actually do it.
Okay, just let me hit pause here, and we'll let you knock that out. So if we were to take a normal approach to this, what you might try to do is a single bond. You can tell that's not my handwriting. One of your classmates had attempted to do this. Found out we've got 2 carbon atoms, and a single bond just does not work. So what can carbon and nitrogen and oxygen and sulfur do that all other elements cannot do? Or the majority of them. They can double bond. Is there a triple bond? Okay, only 2 elements can do that. Carbon, not oxygen, and nitrogen can do triple bonds. So then what we see here, if we form a double bond, now we see that there's 4 electrons being shared between these carbon atoms. So there's 4, okay, here's 6 and 8. These are being shared, there's 4, there's 6, there's 8. These bromides, they all have 8 electrons around them. So that is how you do covalent bonding, because again, these electrons are being shared between the elements. Unlike the top 2 we did, those are ionic, where the electrons are completely transferred. All right. There's only 5 minutes left. I'm presuming you probably don't want to ask another question. Okay, so let's look at this list. We've done Bohr models. We've done configurations, maybe not yesterday, but we did record in the afternoon session. We just did dot diagrams. We did naming compounds. We spent a little bit of time with organic compounds, maybe not a lot. But then, what do we have left? Not this, but what do we have left from this list? Chemical reactions. Okay? So, and then what are some examples of chemical reactions? There's 5. 5 types.
Chemical.
That's just one. Nope. How you classify them? Does anyone quite remember? How about decomposition? That's 1.
Oh, synthesis.
Synthesis is 2.
Double replacement.
Double replacement's 3.
Single.
Single replacement. And combustion. Okay, so we will cover more of that tomorrow. Now, because of the afternoon session on Thursday, a lot of those students won't be in class. Some of you students in here will be on the bus for White at this time on Thursday, or maybe down into the lobby consuming your lunch, whichever. But that means that we will have your exam on Friday, not Thursday, because of the track meet. Yes?
They might cancel the track meet on Thursday and move to a Friday. This
Yeah.
Friday.
Oh,
Yeah, it's kind of confusing. Track meet
They said it was in
Thursday
like
gets
storm.
canceled and it'll get moved to
Yeah, if
Friday.
they cancel it during.
okay. We don't need to have this part of the conversation, so we'll know more tomorrow. Either Thursday or Friday, we will let you know that. And keep in mind, everyone has an exam in front of them. It's how you determine, I think I did all right, I want this to count. Or if you think, oh, this is garbage, I maybe could have done more. But anyway, I'll leave that up to you. We'll catch up to you next time.